Hi there and welcome to this video for Senior Physics on Motion. In this video we're going to explore force of tension. Now this will link with some of the work that we've done on forces so far, so this will round everything off with respect to forces. Now basically tension is a force found in connections and strings, and what it does is has the effect of pulling in both directions. Obviously we're going to have a string which is attached to an object. It's also going to be attached to some other point, which means that there are going to be 2 points of tension, one on the object and then that other point. The result is those two tensions act in opposite directions, and we'll explore that later on. But let's take a situation where we've got and just explore what happens when we attach an object via a string to something like a ceiling. So in this case we've got a 0.5 kilogram mass which is hanging on the end of a string from a ceiling. Now the tension is caused by the string by the weight force, 5 newtons, hanging from the mass. Now what we've got is the tension acts downwards on the ceiling due to the weight force of the mass. So you can see there that that second arrow coming down from the ceiling is acting downwards, okay, because this is the effect of the mass. However, the ceiling is also having an effect on the mass by pulling it upwards, so it's holding it upwards. So we've got two directions. Now what we'll notice is that gravity is going to be holding on to that object. So if the object is able to remain stationary, then what will happen is those two tensions sort of cancel out and we've got one overall tension and it will remain the same. However, if the weight force is greater than the tensional force, then the result is that the tension will actually not be able to work and the thing will snap. So it will snap generally about those two arrows. So it may snap in the middle or at the connections, but it will snap. And as an engineer, it's really important that you make sure that if you're attaching anything to another object, that the tensile strength is able to deal with all of the forces which are applied upon it at that specific point. If not, then you're going to need to use another material or design it in a connection in a better way so that it doesn't snap. So let's look at a quick example. So in this example what we've got is we've got a 1 kilogram and a 2 kilogram mass which are basically suspended by springs. The 2 kilogram mass is suspended from the ceiling, and then there's a 1 kilogram mass which is suspended beneath the 2 kilogram mass as is shown in the diagram. So we've got to calculate the size of the tensions in the two strings. Okay, so the first thing we've got to do is draw a free body diagram, which is basically where we do a block and arrow and just basically show where the forces are applied. So we're going to look at the 1 kilogram mass, the one right at the bottom. Now the 1 kilogram mass is going to have two forces applied upon it. Now we know it's stationary, so it's not going anywhere. So we know that the 1 kilogram mass is basically pulled down by the force of gravity, hence its weight force. So it's got the weight force acting downwards and then it's got a tension force acting straight up. Now the weight force will be 10 newtons, which is 1 times 10, the acceleration due to gravity, which means that as a result of this, the tension force is going to be the same because it's acting upwards and it's not moving. Note, Newton's first law says if no force is applied, it will not accelerate. So if it's not accelerated, it's zero, which means its velocity is either constant or it's stationary. In this case, it happens to be stationary. So we've got weight force acting down and then we've got tension force acting up. So that's what's being applied to the 1 kilogram mass. So on the 2 kilogram mass, we've got two forces acting downwards and one force acting upwards. So we've got the weight force of the 2 kilogram mass acting downwards plus the tension force of the 1 kilogram mass acting downwards. They are going to be combined together and must equal the tension force or tension 2 acting upwards. Now the weight force of the 2 kilogram mass is easy to calculate. It's 20 newtons. That's 2 kilograms times acceleration due to gravity, which is 10. So the total force acting downwards is going to be the weight force, 20 newtons, plus that of the tension force from the 1 kilogram mass, which is 10 newtons. So I add those two together. That gives me 30 newtons. Now this has to be balanced by the tension force acting upwards. So my tension force must also be 30 newtons to balance the force upwards. I need to make sure that the tensile strength of that string is able to withstand 30 newtons, otherwise it will snap. So 30 newtons or more of tensile strength will be enough to hold that system in place. Okay, so I've got another example here where we're going to actually cause something to move. Here I've got a pulley and I've got two masses which are applied on the pulley. Now there is a tension which is held between these two masses. There's a tension on a 14 kilogram mass and there's a tension on a 7 kilogram mass. Now these are accelerating. Now you'll notice the direction that the acceleration is occurring. So notice that these two masses are tethered, so their acceleration are going to be the same in both cases. And we've got to work out the acceleration of the system and the tension in those strings on this free-flowing pulley system. Now the pulley system is free-flowing, meaning that there's no frictional forces which are generated. So we're going to treat it as a single line. So we're going to be working on the idea that the whole system, the 14 kilogram mass and the 7 kilogram mass, are moving at an acceleration, in this case to the left, but in the system that we've got on the pulley it's acting downwards. We've got the tension forces acting between the two. Now the 7 kilogram mass is accelerated upwards and the 14 kilogram mass is accelerated downwards. Because they're both tethered, the acceleration must be the same. Now there is an unbalanced force, so we've got to find what is the net force which is going to be generated in each of these. Now we know that the net force will be made up of the 14 kilogram force acting downwards, pulling down, but the 7 kilogram force acting upwards. And because it's going in the opposite direction, we've got to take them away. So I get 140 newtons acting downwards and 70 newtons acting upwards. Because the tension, the force is pulling downwards, the other one is pulling it upwards on that tension of the string. So because they're going in opposite directions, I've got to take them away. So I've got 140 newtons acting straight down, but I've also got 70 newtons acting upwards. So as a result, my net force which is applied is 70 newtons to the whole system. So I've got a net force of 70 newtons which is pulling the whole thing down. But I don't want to find the net force, I want to find the acceleration. Now I know that the net force which is accelerating the whole object downwards is basically going to apply to Newton's second law of F equals ma. So now what I've got to do is that whole system is now going to have a force of 70 newtons pulling it down. Now the system is made up of two masses. I've got the 14 kilogram mass and the 7 kilogram mass. So as a result, I've got the 70 newtons acting on a combined mass of 14 plus 17, which is basically 21 kilograms. So as a result, my acceleration is 3.3 meters per second in a downwards direction. So all I've done is rearranged Newton's second law to convert it and make sure that that net force is applied on the two masses together. So I now know that both masses are being accelerated by 3.3 meters per second. I now need to work out what the tension is in the strings. Now the tension is going to be the same in both cases, but they're going to be acting in different directions. So let's look at the 7 kilogram mass. Now the tension has to counteract the weight force and also be accelerated upwards. So if you think about it, what's happening is it's being accelerated upwards at 3.3 meters per second. Okay, but that acceleration has got to hold it stationary, which is its weight force, plus have an extra force to cause it to accelerate upwards. So the upwards force has got to be greater than the downwards force. So as a result, the tensional force has got to be greater than the weight force. Now I know what the weight force is. I know what the force due to the acceleration of gravity on that mass is. So as a result, I can find my tensional force. So I use this formula here where the tensional force will be made up of the weight force, that's the one keeping it stationary, so that's the tension in the string keeping it stationary, plus the added force which causes it to accelerate upwards. So I get weight force equals m times a. I know the acceleration on that mass. That mass is 7 kilograms, so it's 3.3 times 7. So the tensional force will be 9.1 newtons in an upwards direction. Now, if I look at the 14 kilogram mass, it should be the same, but we should be acting in the opposite direction. This time what's happening is I've got a whole weight force, but it's being held back by the tensional force from that 7 kilograms. So what we've got to have now is the tension force has got to be less than the weight force. Okay, so it's working in the opposite direction. Same thing, but we're just working at it in different concepts using the arrows of tension. So here I've got the tensional force will equal the weight force, but in this case it will be minus the force of acceleration because it's got to act against it. Otherwise it would just fall with exactly the same with the weight force. So it's been accelerated down not at 10 meters per second, but at 3.3 meters per second. So it's being slowed down. How's it slowed down? Due to that motion of the 7 kilogram acting upon it. So it's the weight force of that mass, which is 14 kilograms times 10, which is 140. Take away the acceleration, the force due to Newton's second law, m times a. So I get 14 times 3.3. So as a result, my tensional force acting on the 14 kilogram mass is then 93 newtons, but in this case it's in a downwards direction. Okay, well I hope you found that useful. I'm also going to put some more videos of exemplary questions so that you can have a go and practice, and then those will help you with your exams. Okay, well I hope you found that useful. That basically concludes all the work that we've done on force in this unit. So again, I hope you found it useful. Thank you for joining me, and I look forward to meeting you again. Bye for now.